view, the biggest mistake is that they're trying to use an energy systems, that's too intense for the time domain of the session that they're trying to do. So let's say you've got an 800-meter run. They try and use purely fast glycolysis, which you might use for a 400, for an 800. What happens? Their body is filled with hydrogen ions and they crash. Okay? This is the biggest problem. Maybe they're trying to use this when it should be this. Maybe they're trying to use this when it should be this. They use an inappropriate energy system. Now, obviously, if we can push that threshold higher, we have a higher yield, we can perform at a higher rate. Remember, we talked about that yesterday. If you can run an 800 meter at a pace that someone else is doing 400, because your anaerobic threshold is higher, you will perform better than them. They try to use an energy system that's too intense for the workout that they're doing. As a result, they reach a threshold, a point between the two energy systems, and the byproducts of the energy system inhibit their ability to stay in that system. Therefore, they hit the wall and intensity, and therefore their output drops. Imagine that I'm in a car, and I drive that car into a wall, and it crushes the bonnet of the car. I've hit the wall, literally. It then takes a lot of work to repair that car. A lot of work to repair that car. If I were to stop 1,000th of a millimeter before that wall, the car is completely unscratched. 100% fine, and I can reverse up, drive away, and be absolutely fine. A centimetre more, and my bonnet has been crushed by a centimetre, the entire front of the car. That wall is your threshold. If you hit that threshold, you're in trouble. You can't recover from it. Same thing when you're exercising. When you hit that point that I've gone too hard, it's too late then. This is the problem, using an energy system that's too intense for the length of that workout.